welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. So here we're gonna discuss about the same, and that is we'll just start discussing about the another new topic that we had last completed the general electronic configuration and oxidation state of a p block element, where we discussed about the detailed general electronic configuration, first member of the group oxidation state, other oxidation state as well. Now we talk about another one. We'll start with group 13 element, that is the boron family. Then after that, in group 13 we'll discuss about the electronic configuration, atomic radii, ionization, enthalpy, electronegativity, one by one. So let's get started. The first we talk about it is the group 13 element. Group 13 elements, which is the boron family. Now in the boron family we talk about it. So here the group elements that shows a wide variation of properties, where boron is a typical non-metal, aluminum is a metal but shows many chemical similarities to boron, and gallium, indium and thallium are the most exclusively metallic in character. We are talking about boron, that is a fairly rare element, mainly occurs as orthoboric acid, which is H3BO3, borax, that is Na2B4O7.10H2O, and kernite, which is Na2B4O7.4H2O. In India, borax occurs in Apuga Valley, which is in Ladakh, and Sambhar Lake, that is in Rajasthan. The abundance of the boron in the earth crust is less than 0.00001%, that is by mass, and there are the two isotopes of forms of boron, which is 10 boron, and that is 19%, and 11 boron, that is 81%. Aluminum is the most abundant metal, and is the third most abundant element to the earth crust, which is 8.3% by mass, and after oxidation 45.5%, and Si, which is 27.7%, bauxite Al2O3.H2H2O, and the cryolite, that is Na3Alf6, are the important minerals of the aluminium. In India it is found as mica in Madhya Pradesh, Karnataka, Orissa, and of course Jammu. Gallium, indium and thallium are the less abundant elements in the nature. The atomic, physical and chemical properties of these elements are discussed. We will discuss about one by one, and the first we'll discuss here with the electronic configuration. So as I told you, please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and you can also enjoy the video as well, and we will provide you more and more important topics and more subjects that you will require. This is NCRT solution, or with respect to each and every question that we will be solving here. So the first category we will discuss here, electronic configuration. In terms of electronic configuration, the outer electronic configuration of these elements is Ns2Np1 for group element 30 in the boron family. Ns2Np1. Now a close look at the electronic configuration that suggests that while boron and aluminum have a noble gas core, gallium and indium have unnoble gas plus 10d orbital electrons, and thallium have noble gas plus 14f electron plus 10d electron cores, and thus the electronic structure of these elements are more complex than for the first two group of element that is discussed in the last that topic we will discuss about the unit 10. This differences in electronic configuration structures affects the other property of the consequently the chemistry of the elements of the group as well. Now we discuss about the atomic radii. In terms of atomic radii, on moving down the group for each of the successive members, one extra shell of the electron is added, and therefore the atomic radius is expected to increase. And however, the deviation that can be seen atomic radius of gallium is less than of aluminum, and this can be understood from the variations in the inner core of the electronic configuration, and the presence of additional 10d electron offers only poor screening effect, which is we had discussed in the unit 2, for the outer electron from the increased nuclear charges in the gallium, and consequently the atomic radii of the gallium, that is 135 pm, is less than that of aluminum, which is 143 pm. Okay, so I just write it down, the atomic radius, of course. Atomic radius of gallium, that is your 135 pm, and your for talking about for aluminum, it will be 143 pm. Okay, so as you can see the differences. Now we'll discuss about the ionization enthalpy. This is the ionization enthalpy. The ionization enthalpy value, as expected from the general trends, do not decrease smoothly down the group. The decrease from boron to aluminum is associated with increase in size and observed discontinuity and the ionization enthalpy values between aluminum and gallium, and between indium and your titanium, are due to the inability of D and F electron, which have those screening effect to compensate the increase in nuclear charge. The order of ionization enthalpy that has been expected, so which is that the sum of the first three ionization enthalpy for each of the element is very high. Effect of this will apparent when you study their chemical properties. Now we discuss about the electronegativity. That is the fourth one. In terms of electronegativity, down the group, the electronegativity first decreases from boron to aluminum and then increases marginally. This is because of the discrepancies in the atomic size and the element. Okay, now we'll discuss about the physical property, and that is after that we'll discuss about the chemical properties as well. So physical properties. in physical properties, boron is non-metallic in nature and it is extremely hard and black colored solid, and it exists in many allotropic forms due to the very strong crystalline allotropic form, and that is due to very strong crystalline lattice. Boron has unusually high melting point. Rest of the members are soft metal with low melting point and a high electrical conductivity. It is worthwhile to note that the gallium is with unusual low melting point, 303 Kelvin, would exist in liquid state during the summer. Its high boiling point, which is 2676 Kelvin, makes it useful material for measuring the high temperature density to the element that increase down the group from the boron to thallium. Now we discuss about the another one, which has been the chemical property, and that we'll discuss in the next coming class. So here we're going to end up with this only, and that will continue. So before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and another you can also enjoy the video as well. So we'll discuss in the next coming class about the chemical properties, oxidation state, trends in the chemical reactivity, atom and physical property of the group 13 element, then reactivity towards air, reactivity towards acids, alkaline towards halogen. इसीलिए मैं अभी नहीं शुरू कर रही हूँ because it's a long topic. मैं अभी में करके फिर next करूँगी तो of course आपको वही class में नहीं मिल पाएगा. So that is the reason why I stop here. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.